Good morning, sir. Myself, Pujita. I am studying in BTech first year in Srinivasa Ramanujan Institute of Technology. I am from ECE department. Subject Engineering Physics. Subject code 23PHY01. My roll number is 244Z1A0492. Today my topic is drift currents. Now we will discuss about introduction to drift currents. Drift currents are the result of the movement of charged particles in a medium. They are primarily influenced by electric fields and temperature gradients. Understanding drift currents is essential in field like material science and electronics. Electrical current, movement of charged particles, current direction coincide with the direction of movement of positive charges. Ordered movement of electrons in a metallic conductors and the current I. S equals to cross sectional area of the conductor. E equals to electric field. Coming to the next one. Definition of drift currents. Drift currents refer to the flow of charge carriers in a conductor or semiconductor. The motion of these carriers is driven by external electric fields. This phenomena is distinct from diffusion currents, which are driven by concentration gradients. Mechanism of drift currents. Drift currents occur when an electric field is applied across a material. The electric field exerts a force on the charges carriers, causing them to accelerate. As the carriers gain energy, they move in the direction of the electric field, creating a current. Coming to the next one. Factors affecting drift currents. Several factors can influence drift currents, including temperature and material properties. Higher temperature can increase carrier mobility, affecting current flow. The type of material, conductors, semiconductors, insulators also plays a critical role. Factors affecting drift. Spray characteristics, chemical formulation, drop size, evaporation, equipment and application, nozzle type, nozzle size, nozzle pressure, height of release, weather, air movement, direction and velocity, temperature and humidity, air stability, inversions, topography. Coming to the next one, drift velocity. Drift velocity is defined as the average velocity that a charge carries attains due to an electric field. It is directly proportional to the strength of the electric field applied. Drift velocity can be calculated using the equation V into D equals to mu into E, where mu is the mobility of carriers and E is the electric field. Application of drift currents. Drift currents are integral to the functioning of electronic devices like transistors and diodes. They are also significant in the designs of photovoltaic cells and batteries. Understanding drift currents helps improve the efficiency of electronic circuits and materials. Coming to the next one, drift currents in semiconductors. In semiconductors, drift currents are crucial for device operations. Charge carriers in semiconductors can be electrons or holes, each contributing to the current. The movement of these carriers under an electric field is what allows semiconductors to function in electronic applications. Drift current versus diffusion currents. Drift currents arises from external forces while diffusion currents are driven by concentration gradients. Both types of currents coexist in materials contributing to the overall current flow. Understanding the distinction is vital for analyzing electrical conduction in various mediums. P type holes, N type electrons. Challenges in drift current measurements. Measuring drift currents accurately can be challenging due to noise and other factors. Specialized equipment and techniques are often required to isolate drift currents from other effects. Understanding these challenges is essential for researchers and engineers working in the field. Drift in measurement basic concept, electrical and electronics measurements. Conclusion for the topic. Future direction in the drift current research. Ongoing research is focusing on improving materials to enhance drift current efficiency, novel nanomaterials are being explored for their unique electrical properties. Advancements in this area could lead to the development of faster and more efficient electronic devices. Thank you, sir, for this opportunity.